Welcome to today's webinar, The Hottest Mapping Trends, live from the ESRI User Conference in San Diego and brought to you by GPS World Magazine and our sponsor, NavCom. I'm Joelle Harms from North Coast Media, digital producer for GPS World Magazine, and I'll be your event manager. Before we get started, I want to let you know today's webinar will be recorded. You are currently in a listen-only mode. The recording will be available tomorrow on our website, gpsworld.net/webinars. A link to the on-demand recording will also be emailed to you when it is available. At this time, I'd like to acquaint you with the ways you can participate during today's presentation. Please notice the Submit button in the lower left-hand corner of your console. We encourage you to ask questions throughout the presentation. Just type in the text box at the bottom left, then click Submit to place your question in queue. Questions that were submitted during registration may be covered in this webinar. Some questions may also be answered in an upcoming issue of GPS World Magazine or in our e-newsletters. We strive to answer as many of your questions as possible. Finally, if you experience any technical difficulties during today's event, select Help to submit your issue, and assistant producers Bethany Chambers, Diane Safranik, or I will personally assist you. Now I'd like to turn today's event over to Group Publisher of GPS World and Geospatial Solutions, Alan Cameron.
Good morning, everyone, and welcome to sunny San Diego, where the skies are blue and the maps here at ESRI are every color of the rainbow, and then some. I'm Alan Cameron. Today's webcast, as Joelle mentioned, is made possible by the generous support of NavCom Technology. We're here at ESRI to talk about the use of mobile devices, cell phones and tablets across surveying and mapping applications, particularly involving RTK. Also the role of UAVs or drones and the new capabilities they provide. Finally, the rising importance and availability of real-time info. There's no one better to guide you through the intricacies and new developments in these fields than Eric Gackstatter, our contributing editor for Survey, and as soon as we manage an equipment handoff, the next voice you hear will be his.
Hey, thanks, Alan. Hey, it's great to be here at the ESRI 2014 International User Conference, and boy, it's a great event. I come here every year along with the crew here from GPS World and Geospatial Solutions. And I'll sort of give you try to illustrate for you where we're at. We're on the second floor of the convention center. It's a huge facility. There's 515 presentations being given today, if you can imagine, among all these rooms. I don't know what the room count is here. So we're up outside of room 27. There's lots of traffic going by the podcast booth. We're in about a 12 by 15 foot glass enclosed booth with lots of stickers and labels on the outside letting folks know what we're doing. And then there's the exhibition hall downstairs with a bunch of aisles. I'm not sure how many exhibitors are here, but lots of technology going on. So sort of the background of this is we thought we do a lot of these webinars. I've done many in the past, but we thought we really need to do a live event here at ESRI, and I think it may be a first as far as I know. So the agenda today, and actually before I forget, the neat part about doing a live event is we can sort of bring in guest speakers from the show floor or planned in advance. But we've got a gentleman named Sharad Garg here today. Hello, Sharad. He's a iOS expert and GIS expert. He does lots of ESRI stuff. I think you're on mute there, Sharad.
Glad to be here. Thank you.
Yeah, fantastic. Good to have you. And then I'm expecting maybe a drop-in or two from the show floor, hopefully from ESRI, but we'll sort of take that as it comes. That's a neat part about doing a live event. I'll push out a slide there just with the big welcome sign. You imagine the scale of the Superman GIS there. That's sort of a central theme or a central logo that you see here at ESRI. And here's the agenda I've just displayed for you. We're going to talk about a few things. We're going to hit RTK and Submeter on mobile devices, and that being smartphones, tablets, based on Android, iOS, Windows. Going to talk about a bit mobile GIS and touch on UAS a little bit because that's been a super hot topic lately. And then some ideas on real-time info, and I'll get into that a bit more towards the end. And we've got a ton of audience questions. There was probably over 100 pre-registration questions, and then I've pared those down. We've got a few others to to tackle, and we'll probably get to some live audience questions too. But if we don't hit them all here, if we don't answer your questions, I'll address it in my next newsletter. So here's just a really quick, just if you hadn't had a chance to go to the ESRI website, they have videos of the plenary, of course featuring ESRI President Jack Dangerman. And it's sort of his theme this year was geography into everything we do, and it's very geography is becoming much more integrated into not just a professional arena like we work in, but we're starting to see it, of course, more and more in the consumer space too. So let's talk a bit about the mobile device landscape, and I've written a lot about that in the past in geospatial solutions, and it's been interesting. And if you look back, I don't know, 5 or 6 years ago even, if you're going to go out and acquire a mobile device to use with high precision GPS data collection, you really didn't have a lot of choice in terms of operating systems. Really, Windows Mobile was the dominant theme at that time. You'd go buy a rugged handheld, maybe an iPad, which is a consumer-type device, or maybe a rugged tablet running Windows Mobile, or maybe full-blown Windows. But as I've written and spoken about in the past, I think it was 2009, Sherrod. The iPad was introduced. Was that about what it was? 2009, 2010, and really we can attribute Apple as to sort of I think stimulating the explosion of low-cost tablets and smartphones, because after that, after Apple introduced the iPad at the $500 or $600 price point, all of a sudden, Amazon comes out with their $200 tablet, and you've seen all kinds of different tablets and smartphones hit the market from a wide variety of manufacturers. And it's not just iOS now. I mean, Android arguably is the most, I think, popular operating system for mobile devices in the world now, right?
It is.
And I haven't looked at the latest market share numbers, but the last ones I thought I looked at were about 60%, maybe 65% market share for Android, and and iOS was down maybe 30, 35. I could be off a little bit, but I don't think I'm off too far. And then Windows is just a fraction of that now. And so what this has forced, I think, enterprise organizations to make decisions about is, hey, which mobile device are we going to deploy, and how are we going to integrate high-precision GPS or GNSS in with those mobile devices, right? And Sherrod is just some background. He's a consultant in the GIS industry. He's got a lot of exposure and experience, and really experienced in iOS. And so I don't know, maybe you can give us some perspective what you're seeing from your enterprise clients about mobile devices and sort of the decisions they have to face, and maybe there's not an easy solution now.
So right now, basically, previously the enterprises were all about BlackBerry platform, which basically has now become a dinosaur platform. And nowadays we see more and more IT departments allowing people to bring their own devices, and when they allow people to do so, it's obviously either an Android or an iPhone or iOS device. And lately we have seen that IT departments are leaning more and more heavily towards the iOS platform, because it is a little bit more controlled platform. It has a lot more security built into it. It is a lot more closed, so people really don't have that much flexibility to really mess up the enterprise architecture as much. So, and with recent partnership, I think it was announced yesterday with IBM, with Apple, we will certainly expect to see a lot more security-oriented apps and infrastructure come up in the iOS platform.
Yeah, actually, that's a great point with that IBM-Apple partnership. And just to expand on that a bit, I've met with a number of my clients, and it's interesting is that if I get a bunch of them in a group and I say, or I ask them which platform are you using, and invariably they'll say a third of them will say Windows, a third of them will say Android, and a third of them will say iOS. And I think it just sort of illustrates the fragmentation, I think, of the market now. But security is a huge issue, and I know a lot of folks, especially enterprise organizations, talk about this. is, they worry about Android being an open source operating system, right? And they worry about security from that standpoint. iOS, they really aren't sure. I mean, they think since it's a closed ecosystem, perhaps better security, but really, is it in the end? Is there? I mean, if they're targeted by nefarious people, is it really a safe operating system? And will this IBM partnership help that? Do you think?
I certainly think that the IBM partnership would help very significantly because, in the enterprise world, IBM definitely has a big lead. More so, Apple has, with the recent slew of virus attacks and things of that nature in the industry, people are really leery of allowing too much control to the user. So I think that the enterprises will definitely pull back a little bit and try to exert more control on the device types that are allowed to connect to the network.
That's a good point. So I guess for those of you who aren't as maybe tech-oriented, why does the operating system make a difference? And actually, it makes a huge difference because it comes down to, I think, the apps, right, Sharad, for the most part. I mean, if apps are written for particular operating systems. So, for example, ArcPad is a great example. Esri ArcPad. It's written for the Windows Mobile or Windows operating system. It doesn't run on Android platforms, and it doesn't run on iOS platforms. And so when an enterprise that is centered around ArcPad as this data collection software wants to go out and try to use Android or iOS devices, they're going to have to switch platforms at that point, right? And so that's why the operating system makes a huge difference. And now what's more interesting, is that the smaller the software vendor is, the less they can afford to support all the different operating system versions and iterations, right? I mean, it's a serious problem because it takes a lot of resource to do it. And folks like Esri and others have huge software development teams, and so they can afford to have a team assigned to iOS, a team assigned to Android, a team assigned to Windows Mobile, Windows Phone. I mean, the folks in the audience, you see this list on the screen right now that's showing the 5 major operating systems out there, and all of them more or less have a different development environment, right, Sharad?
Yes. Actually, there are some open source third-party toolkits available that allow you to kind of develop in a cross-platform environment, but those things are generally at a very high level, very basic level. The kinds of things that we like to do in the GIS world with the integration with all the different hardware components, it's very hard to see an effective user experience based on a cross-platform environment. It's much more richer user experience to develop a focused, platform-focused app. Yes.
And folks have talked about in the past having a web browser-based type of application, right? Because, if you've got a web browser, which all these devices do, they're saying, hey, why can't folks develop in a web browser environment and deploy apps in that way? What do you think about that?
Web browsers are good for pushing content to the people, but web browsers kind of, in my opinion, fail in some sense to take the full advantage of the device offering. So, like the gyroscope that we have in the device, or the compass that we have in the device, and the GPS sensors that we have in the device, there's a layer of abstraction there between the web browser and the device sensors, which I think prevents an effective user experience when we use strictly a web browser.
Yeah, I've seen the same thing. I've used some web browser-based apps across platform, and they aren't as snappy, they aren't as responsive. They're a bit frustrating when you've been used to using a natively built application for the device. At least that's been my experience. Now, there was some talk at this show about this new Qt tool, right? Can you talk a bit about that?
Yeah, that tool has been around for a while, and really kind of the pioneer development platform at this point that allows or claims to allow for a complete cross-platform development. And they have built abstraction libraries that kind of are platform-specific. So you kind of work on top of the Qt platform, and you kind of compile against an iOS platform or an Android platform, and behind the scenes, they actually do the transformation of making the calls directly to the native platform. But I don't think that it has been tried and tested enough yet to be the end-all, be-all solution to this platform war that we see these days.
Okay, I get that. Yeah, it's a new. I've sort of heard about this technology in the past, but I think you're right. I think it's got to be proven before we can really talk much more about it. We actually have to deploy some apps and see how they work cross-platform. So let's move on to submeter and centimeter accuracy on smartphones and tablets, because I get tons of questions from people about, hey, how can I integrate submeter or centimeter GPS accuracy into my smartphone or my tablet. So let's talk a bit about that, and really it comes back to I guess the operating system is a part of that, but then just in general the way that communications works, especially Bluetooth, between GPS receivers and the mobile devices. And historically it's been pretty easy on the Windows and Windows Mobile environment, where Bluetooth has been really a replacement for the cabled solution, and it appears very much like a cabled solution because you can set up your COM port, you can set up the baud rate and the rest of the protocol, and the Bluetooth link just appears like a serial link, right, an RS-232 link. And so it has been pretty straightforward, but iOS and Android are a different animal altogether. They don't behave that way at all. And can you talk a bit about that, Sharad?
Sure. Eric is absolutely right that Bluetooth was kind of professed as a true cable replacement technology for the longest time. But with the advent of iOS and Android and their implementation of Bluetooth, the way they view Bluetooth services, it has radically changed the game. They believe Bluetooth to be more like a service provider, so be it a keyboard is a different service provider from a mic or a headset, and different accessories have different capabilities. GPS obviously being a fairly unique one, being able to provide location information to the physical device. So all of these platforms have some sort of a wrapper around the core Bluetooth stacks, and those wrappers basically govern what you are able to and not able to do at a given time. For example, in iOS, certain device types are allowed to connect without any significant effort on behalf of the accessory manufacturer. So if you have a Bluetooth keyboard, you can easily connect to the iOS device. But say if you have some random Bluetooth accessory, which is not a keyboard, which is not a HID device, there's no way you can connect to it unless Apple approves it, because there's a authentication chip that Apple requires you to have in the devices. Android is a little bit more open in that respect. Android still allows you to access the lower layers of the Bluetooth stack and write an app that would access those Bluetooth functionality feeds and make it available to other apps or even the core OS. Whereas Apple has taken the stance very much so that if you want to talk external accessories, you really have to kind of get my permission and get our authorization and approvals before we allow you to communicate effectively with external devices.
Yeah, that's a good summary. Let's talk about iOS a bit. And I want to emphasize a point that Sharad mentioned, and because lots of folks out there will say, hey, I've got a Bluetooth GPS receiver and my iPad's got Bluetooth capability. Why can't they talk? And the bottom line is that Apple controls that environment quite tightly. And what Sharad said is that you need to have a Bluetooth authentication chip inside your device. And so if you have a Bluetooth receiver and it wasn't built specifically for Apple, doesn't have that authentication chip, and hasn't been through the Apple certification process, it's not going to work. And there's no way to make it work. And so therefore we see very few receivers out there built specifically for the iOS devices, because, and tell me if I'm wrong, Sharad, but And actually, the technical part of getting a Bluetooth receiver and an Apple device to talk together is really not that hard. But boy, the Apple certification process will run you through the ringer, right?
Yes, actually, we learned it the hard way, Eric. It took us a good 8 months to get our first certification through, and the way Apple, it's not just for GPS devices, the way Apple behaves is that for every accessory that wants to talk to an iOS device, Apple evaluates that very, very carefully. The use case for it, the user experience, the end product, all of it. So it's not like Apple just lets you go out and create whatever product you want. Apple wants to be involved in every step of the way. They review the business case, the use case, and approve it. Only then can you move to the next step. And each of those steps take anywhere from 3 to 4 weeks. That is, if you get it approved in the first round. So I think that it's a good thing and a bad thing, because this kind of prevents some of the lower quality, lower user experience accessories to come to the market connecting to the iOS device. But at the same time, there are some legitimate use cases where if Apple does not feel, quote-unquote, safe, they can prohibit you very easily. You know, a prime example is automated vehicle control. Apple has kind of made it very clear to us, because we tried to approach Apple a bit with this, and they were fairly clear that they don't want Apple devices controlling the movement of the vehicles in the tractors, fields, whatever. So, you know, as soon as they see such use cases, they'll actually prevent you from moving forward and from bringing that accessory forward. So it's a good thing and a bad thing in some sense of shape.
You know, what I've noticed, and I've got some experience with Bluetooth and iPads, is that the Bluetooth interface, but once you've gone through the whole Apple certification process and got your product working with iOS, the Bluetooth connection stuff is so easy. I mean, you turn on your app, your iPad, you turn on the receiver, and within probably 3 or 4 seconds, it automatically connects. You don't have to worry about choosing the COM port, the baud rate, or anything like that. So that part it's a really a nice user experience, much more than the Windows environment. But the challenge of that is that you when you do have that Bluetooth connection, it's not like you can just see NMEA data flowing into the iOS device, right? There's this whole core location concept. And can you talk about that for a minute, please?
Sure. So the way Apple has designed this, Apple basically said that all my devices have GPS built in. So Apple treats location as a core component of the OS. From a consumer perspective, Apple really didn't have the professional GIS geeks in mind when they were designing their products. But from a consumer standpoint, Apple just said people are interested in knowing their general location, more like, you know, finding directions on Google Maps and where am I kind of things. So Apple abstracted all of that location details that we really look for from a professional GIS standpoint. They abstracted all of that and kind of dumbed it down very, very significantly. And at this point, there are multiple sources of location that Apple works with. So cell phone tower triangulation is one of them. Your IP address, the device is connected to Wi-Fi network, and hence it has an IP address, and Apple will reverse map it to figure out where your location is. And then last but not least, GPS is obviously present as well. So Apple looks at all those different sources of data, calculates what it thinks is its best guess based on whatever best available sources are, and gives that location back to the user strictly as a X, Y, and Z location. And very recently, I think it was in iOS 7 and above, Apple started, it was iOS 6 and above actually, Apple started producing some level of accuracy that it thinks the data would adhere to, and has started publishing that. But testing has shown that it is highly, highly, highly unreliable at best. the accuracy reading, I mean.
Yeah, so if we feed it, for example, if we've got it connected to a submeter receiver, let's say an iPad, for example, and it's getting submeter positions, it's sort of difficult to know. There's no flag within iOS that tells you, hey, you're getting 70 centimeters accuracy. It may just tell you you're getting a flat 5 meters and just say 5.00, something like that, because it's not deriving that accuracy information from the receiver. It's just making some assumptions, right?
Yes. In fact, like Apple has a very general concept that, you know, if it thinks that you have a GPS fix, any type of fix, then you are 5 meters or better. It doesn't really rely on the true accuracy numbers that we can actually derive from the whole GPS data set.
Yeah, so you end up needing an app, some kind of app within iOS separate from your data collection program or integrated into your data collection program that will read that information from the receiver, and it's got to be a pretty specifically designed piece of software to do that. And there's some out there, but it's pretty limited right now. And the other issue to talk about is the whole datum transformation thing, and I've bounced on this a lot of times over the past 3 years, and I was hoping Kevin Kelly, the geodesis from ESRI, would stop by because he has some opinions on that too. And he's been working behind the scenes within ESRI to sort of implement high precision datum transformations. It's not there yet, but hopefully we're getting some traction that way. But I mean, the problem we have now, especially when we start to integrate high precision GPS into Android and iOS environment, is that we don't have any. The software out there, very little of it. There's some of it, but very little of it was able to handle the datum transformations that we need for high precision. For example, just down here in San Diego, we're testing RTK on an iPad, and there's a free RTK base about 5 miles away, and so we're able to get internet connection, tap into that, run collector, our ESRI's collector product in our GIS, on the iPad, and we're getting RTK into the iPad, no problem at all. We're getting centimeter accuracy, but since the RTK base is referenced to NAT83, and collector is using ArcGIS Online, which is referenced to WGS84, right, Sharad?
Yes.
And so those of you who understand this know that WGS84 and NAT83 differ by about, well, down here I think it's about 3 feet, 3.5 feet. So you see that offset on collector, and within collector, or actually most of ESRI's real-time mobile GIS products, there's no way to do an on-the-fly datum transformation. And so it really becomes a headache. I mean, then I guess you could start playing around with your different map services, and you could deploy different datum to try to fake it and make it line up. But it's certainly an issue, right, Sharad?
Yeah, and actually what we have seen, Eric, is that most people, in fact, not just ESRI, ArcGIS Online, but you talk about Google Maps, Apple Maps, Bing Maps, all of them that provide worldwide imagery services, pretty much all the consumer-facing sites that we have come across all use WGS84. And so it is very confusing for the user when they're looking at a WGS84 background map, and they're hoping that, oh, I have a great GPS RTK connection and my GPS is reporting 5 centimeter accuracy. They're expecting that we will find ourselves exactly where I'm standing in the corner of the house lot or a street line, and often they find that offset, and it kind of goes back to your NAT83 versus WGS84 comment. So it is important to choose either your base map that matches your correction source, or choose your correction source that would give you WGS84 data, at least in today's state. Obviously, we are talking to folks at ESRI and others to kind of be intelligent about it and allow for that on-the-fly transformations like ArcMap allows today.
Yeah, and that's a good point, is that there's software out there, like, for example, ArcPad, ESRI's ArcPad, that does allow you to do on-the-fly datum transformations. And I think ArcMobile does to a certain extent, yes, right, if I'm not mistaken. But when we get to the apps like Collector, ArcGIS for iOS, ArcGIS for Android, they don't have that kind of functionality in there. But the the ESRI audience, I think, and I've looked at some of the presentations here at the conference, is really interested in collector and the sort of lightweight clients out there because, A, they're free. That's probably a big motivator, right? And so you get a lot of excitement about using high precision within those environments, but they're really not built to handle those environments yet. And, of course, I've been sort of pushing ESRI to implement on-the-fly datum transformations because it's only going to get, I mean, as I've spoken before, high-accuracy GPS receivers are only going to get cheaper and cheaper, and RTK and other submeter and other high-precision technologies only going to become more and more prevalent and adopted in a broader sense. And so ESRI and other software vendors really have to pay attention to these real-time data transformation processes. So, and really the same goes for Android. I mean, Android is a bit easier to interface to. You don't have to go through an authentication process. You don't have to go get approval from anybody. You do have to have some smarts in the way you Bluetooth to Android devices, and there's some free tools in the Google Play Store that allow you to do that. And there's also some other free in-trip utilities that allow you to access RTK networks and so on. So there's Android's a bit of an easier solution, but still not as straightforward as the legacy Windows environment. Now, just moving on really quickly on the last point on this slide is smartphone versus tablet. But really, I guess the neat part about it is once you have a solution for iOS, it really doesn't matter if you're using an iPhone or an iPad. Screen size is an issue, so the app has to be built for that screen size, but the interface is exactly the same. Once Apple gives you a certification, it'll work on any iOS device that's available. And you know, Android is not so much that way because Android is a open source environment, and so you have to be careful because manufacturers of devices can tweak Android for the device, and that can sort of introduce issues that are unforeseen. So you sort of have to pick out the specific Android devices that you want to use and sort of quote unquote standardize them. And is that your opinion, Sharad?
Kind of at a broad level, you're fairly correct, Eric. But I would just like to clarify a little bit more. So when we put an accessory through for Apple certification, we have to specify by model which models are compatible with that accessory. So if we provide an iPhone 4S as a compatibility choice, then that accessory is certified for only iPhone 4S. It might work with future generations depending on how the accessory was made, but it is not a guarantee that it will work or not. You know, like for example, with iOS 7, we basically had to go through certifications on all of our devices all over again, just because it was a significant enough change that we had to go through that. And the second thing about Android, I want to elaborate a little bit on that one, if I may. In Android, the problem is that it's an open source system, and just about anybody who has any kind of hardware knowledge can put out a device out there. So you get a wide variety, some tablets ranging from $70 in the marketplace all the way ranging up to $700 in a Samsung Galaxy Tab 10.1. So the accessory that will work with an Android device is largely dependent upon the hardware that is present or absent in the given device. Also, in Android, people are able to put out their own flavors very, very easily. And some of them are Google authorized, some of them are not. And depending on whether or not they are Google authorized or not, the accessories would behave radically differently. So we have to be very, very careful when we talk about Android because, yes, it is a common platform, but two Android devices running same Android 4.1 or KitKat or ice cream sandwich or whatever, they will behave extremely differently depending on the hardware that is provided in them.
Okay, I think we'll take a couple of audience questions that are relevant to this, and I'll state them, and Sharad, you let me know your opinion on those. But So one of the questions was, how do you efficiently develop both Mac and Android applications for a shop that uses both types for work? That's a trick question, or is it?
Wow. At this point, really platforms like Qt are the only options. Android being a Java-based platform and Mac being very anti-Java and completely Objective-C, it's completely two different platforms. And depending on the app that you are trying to develop, if it is a simple forms-based apps, then you can use, there are a bunch of third-party systems out there where they allow you to design the common form, and then you can push the form either to an iOS or to an Android device. But if you have a very highly custom enterprise integrated workflow that relies heavily on the device sensors and 3D simulations and advanced video graphics, it would be very hard to use single stream of development on both platforms.
So do you end up having to have two different programmers who are specialized in both, or can one person do both jobs, do you think?
Very rarely have I seen people that are equally good on both platforms. Generally, they get better, depending on their background, they get better at either iOS or Android, and then people start to develop preferences, and they kind of gravitate towards one or the other. A lot of people will dabble at the basic level into both, but I have not seen very many very good programmers that are good in both.
Does Esri provide a platform or tool set that makes that any easier?
Not really. If you look at their APIs right now, they are similarly structured, so it is not a completely new learning curve, but it is different enough that you need two different apps, two different platforms. With the Qt, Esri is trying to bring both of them kind of in closer alignment to at least allow some basic customizations. Create like basic forms, like the old ArcPad form builder kind of applications. But for any real customizations where you are doing advanced integrations and custom workflows and things like that, you would probably still be stuck in this release at least.
Okay, and another question from the audience is which OS or which operating system currently provides the most functionality and reliability of connection when using high-precision GNSS, iOS or Android?
Wow.
Is that a loaded question or what?
That is a loaded question, and it's somewhat a personal bias, in my opinion. Now, so my response, because of my experience with iOS and the fact that I have been building these accessories for a good 3-4 years now, I have lived and breathed iOS at a lot more granular level than Android. I would think that once a connection is made in iOS, it is very stable. So from a user experience, your choices might be limited somewhat, but once you are comfortable with a given device, be it a Trimble, Topcon, Leica connected through one of our cables or Bluetooth solutions or one of the built-in GPS receivers, all of those are very, very stable connections. Whereas in Android, yes, you can make it work out of the box by using the Bluetooth, and then you're always relying upon a third-party utility like a BT GPS app that would take the stream from that Bluetooth source and re-emit it for the Android device for other apps to use. In my opinion, they are a lot more unstable and a lot more unreliable, because when something goes wrong, it's very late in the game that you realize that something has gone wrong, and it's very difficult to track down at what point it went wrong. Whereas with an iOS device, the connections are more hardware-oriented. They are dedicated connections, and they seem to be a lot more reliable.
Yeah, I think the point to make is with the iOS interface, you actually have to have an Apple authentication chip in the receiver itself, and that's probably I mean, that certainly contributes to the reliability of the connection because you have much, much more control over it. The downside is that there's just not a lot of receivers out there that have that compatibility yet. And I've got both. I've got user experience with iOS and Google, Android, and Windows. I've used all three with RTK. And I agree with in the Android environment, although there are some companies I know that are integrating in-trip applications and other Android-specific software within their software to interface to RTK receivers, and those are working really reliably. I've used those. But for a person off the street who's just, okay, let's say they want to use ArcGIS for Android, and they say, hey, I've got a Bluetooth receiver, either a Submeter or an RTK receiver. True, they've got to go to the Google Play Store, grab BT GPS or some app like that to make sure that it's taking a position from the RTK receiver instead of the internal receiver on the device and that sort of thing. So there's a couple more humps you have to or hoops you have to jump through to make that happen. But I'll defend Android a little bit in that if you've sort of done it a couple times and you know what you're doing, I've run Android apps with RTK quite a bit and with no problems at all, and I've got several clients of mine that are doing the same thing. And so I see your point there, and I agree. I think the Apple environment for sure, since it's so much more controlled, is a more, I guess, stable connection, I suppose. Certainly from a user perspective, when you turn on the iOS device and you turn on the receiver, I mean, they sync up within a few seconds. It's not that straightforward typically with the Android environment unless you're using an app that was written specifically to do that type of job.
Okay.
Well, very good. So let's move on to the next subject really quick. This is RealTime Transactions mobile GIS. And the reason I brought this up, and I kind of threw this in at the last minute, is I'm really keen on sensor-based or sensor technology, and that it's contributing to this whole big data topic that we think about. Because if you think about it, I mean, GIS software is so powerful today; it can do so many things that really the bottleneck is data. Is how much more data can you feed into it to get your results? And so, and I didn't have time to put a picture in here, but I took one on the show floor yesterday of a company, V-Alarm, down at in the Z booth area that's got all kinds of neat little sensors hooked up to a Android phone. I mean, they had through a USB hub, they had an A to D converter, they had temperature sensor, they had probably 5 or 6 sensors hooked up to this USB hub that was then hooked up to an Android mobile phone, and being able to collect data. And in their case, it was in vineyards, if I recall correctly. But they could mount all these sensors on a tractor, collect all this data in real time, feed it to an Android phone, and then publish it on the cloud, so their clients could view all this data in real time as it's being collected, and just allows for some fantastic, really fast decision making. And the article I wrote this week in Geospatial Solutions really talks about this point a bit, is this whole idea of real time. People don't like to wait for answers. They want accurate information. They want it real time so they can make fast, accurate decisions. So if you have a chance, you might want to read that article. But it touches on the same sort of subject that we're speaking about here. And if you can see the picture on this particular slide, and it's not that great. It's one I took at the plenary, but it shows. I think this was either the city of Minneapolis or the city of Rancho Cucamonga. But anyway, it just shows the different real-time solutions that they've deployed. So either city employees and or citizens can have access to real-time information, whether it's E911 calls or police dispatch or fire dispatch or potholes or manhole covers that are being disturbed or something like that. But the whole idea is that we're really encroaching, I think we're approaching the ability to have some really serious real-time information. And so I just wanted to touch on this subject a little bit. And this next slide that I'll display it's interesting. It's actually, last year at the UC, this is Will.i.am up there on the screen. He's a pretty famous pop artist. Last year he made a live appearance here at the ESRI UC, and it's kind of an odd partnership to see Jack Dangermond up on the stage with will.i.am. Different generations, different backgrounds, different cultures. But I was really impressed with will.i.am and the way he spoke about not only education but reaching young kids and that sort of thing. But he's actually a fairly good technology driver. This picture up in the upper left-hand corner is a watch, a smartwatch project that he is behind. And during the plenary, they actually showed real-time directions being given on the smartwatch. It's actually got a map display, and it's almost like having a auto GPS unit in the dashboard of your car. But anyway, he couldn't be live this year, but will.i.am dialed in from Australia, and so he's really engaged in this technology. And I wanted to bring it up and just show you it's another sensor out there that people will have. And I think there's if we start thinking about, hey, do we really need to carry around a smart or a smartphone or a tablet? Can we do some of our jobs using a smartphone? I mean, a smartwatch where you've got a 2-inch square screen or a 1-inch square screen on your wrist that you can use for even GIS data collection. I mean, you can imagine, having a high precision receiver somewhere on your body connected to a smartwatch, and you can go out and take, fire hydrant or water valve locations or any number of different features. It's just it sort of makes you think about different ways that we'll be able to map really accurately in the future. And remember, a couple of years ago at the GPS World Dinner at the ION conference, it's the big sort of GNSS conference of the year, a gentleman out of the University of Texas predicted that we'll have RTK in our smartphones by the year 2020. So that kind of dovetails into that. Next subject I want to touch on a little bit, and this is, boy, you've heard about this a lot in the press these days, is UAVs and UASs. I mean, it's just there's a lot of noise about these devices out there, especially in the U.S. here, because the FAA has not certified commercial UAV operations or has not released rules for commercial UAV operations in the U.S. And there's been a lot of controversy about this because there's actually a set of rules out there for hobbyists, they call them modelers, to use UAVs, and there's a specific set of rules about this. And so the modeler rules is that you can fly up to 400 feet, and if you're a certain distance away from airports, of course, but you can fly up to 400 feet, and as long as you're being safe and so on. And that rule's been around forever, at least that advisory. It's actually an advisory put out by the FAA. But, of course, in the last couple of years, or a little bit more possibly, is that UASs have become much, much less expensive and much, much more available. And it's just the technology is teasing people because they know it's going to be really productive. If you can imagine, in agriculture, they can use UAVs to fly over fields and take aerial photos and really high-res photos in a really quick turn type of environment. So they don't have to hire a manned aircraft to fly the fields and so on. But just a huge number of applications for UAS in the commercial arena. But again, the FAA has not released rules for commercial UAS operations. And I've written a lot about this. If you go to Geospatial Solutions website, and I've got probably 3 or 4 articles up there about this, and a lot of background on the FAA rules and such. But the rules haven't changed. I mean, it's still there are no rules out there unless you have a certificate of authorization from the FAA. There are no rules to fly commercial or fly UASs for commercial operations, and that includes, according to the FAA, that includes flying a UAS that you bought on your own farm, because that's considered commercial. Even though you're not hiring out to somebody, even though you're not directly making money for it, it's still being used for a commercial operation. And according to the FAA, that's against the rules. Now, there was a sort of a landmark case just a couple of months ago where an NTSB judge ruled against the FAA, where they were trying to sue a guy who was using a UAV for a commercial project. The FAA tried to enforce action against that person, and they failed to do so. The NTSB judge said, hey, you don't have any authority to do that, and so you can't. And so, of course, the FAA is appealing that. So that sort of sent a message to the community, and I think we probably saw a big uptick in UAS usage or at least people are feeling more free that they're able to use UAS for commercial operations. But the bottom line is the FAA still says it's against the rules, and I think just a couple of weeks ago they put out a clarification position, I think it was, on the use of UAVs for hobbyists. So they're trying to really draw that line. I've seen a few more court cases where the FAA has, not court cases, but a few more attempted enforcement actions by the FAA, and I think you'll probably see more and more of those. But so the FAA rules are due to be clarified by September 30, 2015. I think that's the last hard date that I saw. But there's been lots of rumors and such and reports that they're not going to make that deadline. But I just wanted to touch on that a bit. There was a neat paper about it here at the UC that I went to. And this particular slide here just shows a couple of different types of UAVs. There's a fixed wing type, the airplane style, where they travel at a fairly good clip. And then there's a rotary blade, the helicopter style UAVs that are also fairly popular. I'm going to display this next slide here, just showing an example of how effective a UAS was used in an inspection of a transmission power line. And I'm sorry I didn't get any better pictures or clear pictures, because actually one I wanted to show really showed this particular defect fairly well. But anyway, so this company, they got a certificate of authorization from the FAA jointly with the university as a research project, I believe. But the research was to inspect a power transmission line. It was a pretty significant one. It was a 250-foot high tower that supported these transmission lines. And so the project was to use a quadcopter or a helicopter UAV to inspect these transmission lines, these transmission towers. And so they would start from the ground and they would fly up and inspect it along the way. They had a high resolution camera, video, I think, and still pictures on the UAV. They flew from the bottom all the way to the top, and of course focused on areas where they thought there might be issues or possible issues. And anyway, in this particular project, they got to one point on this transmission line, and they found a bolt that was ready to fail. And the owner of the transmission line looked at that and said, this right here, paid for all the project. It was worth it. It's worth it. It was, all the effort that we put into this was worth it. And you could see a red arrow there where I tried to emphasize the bolt. And again, there's a much closer up picture, and I wrote about this in the article this week in Geospatial Solutions. And if I get a hold of that detailed picture, I'll post it up there too. But anyway, it shows this bolt ready to fail, and that if it would have failed, or it would have caused they said it's somewhat of a significant blackout. And so, just one of the applications of UASs out there. Again, there's tons of them. There's a tremendous amount of pressure on the FAA to release the rules so people can start using these for commercial type applications. They did about a month ago release the first, or approved, the FAA did approve the first commercial application of UAS up in Alaska I think it was for pipeline surveys. So there's some progress being made, but there's just a tremendous amount of anticipation and I think desire for folks to use UAS in these different environments, and largely again in geospatial type of environment. And just look for rules, look for follow-up articles in Geospatial Solutions on any updates you see on the FAA rules. There's lots of stuff going on now. There's actually a couple of open federal registers looking for public comment. For example, the Motion Picture Association of America made a request to the FAA because they want to use UASs for movie production, that sort of thing, and they're asking for special exemptions. And there's a couple others up there that are actually open for public comment towards the end of this month, or expiring the end of this month. So I'm going to display right now the slide with my contact information as well as Alan's, but I've got some audience questions that we'll try to tackle really quick here before we sign off. We've got about 5 more minutes here. And And so I'm just looking at a couple here, and actually, this is a good one here. And the question is, have there been any developments, and then this is back to RTK on smartphones and tablets, have there been any developments in the same vein as libRTK for Android or iOS? And I think what the question is referring to is RTK lib, which is a open source RTK algorithm library that's available. And so I think what the user is, or the questioner is getting at is there any open source RTK libraries out there that would allow iOS or Android developers to integrate that type of RTK technology on smartphones or tablets very cheaply? And I think the answer is that the answer is, and I've heard this, and I'm not an RTK engineer or a GNSS engineer, but I know a lot of them, and I've talked to a lot of them, and it's just RTK algorithms are not something that any software developer could really do very well. It's a very specialized field. It takes a lot of energy and a lot of resource to develop rock-solid RTK algorithms. And those of you who have used RTK in the past or do now know that there's nothing more frustrating than you're out in the field and you're working, and all of a sudden, for whatever reason, it loses a fixed solution. You're not at centimeter accuracy anymore. You're waiting around for it to reinitialize. And that's the receivers that perform better in the field in that respect are the ones that you really tend to rely on. And I think it's just at this point in time, it's a very, very specialized field. Yes, I think you're going to see some open source RTK receivers out there, and yes, it will improve over time. But today, I don't think we're there yet. I think there's probably a dozen specialized companies out there that really do a good job of RTK, creating RTK algorithms, but it's not an easy task to do. Another question is, I recently saw a 3D printed map. This is a sort of a different technology we haven't spoke about yet. I recently saw a 3D printed map of San Francisco, including terrain and buildings. Is this a hot new trend? Well, and maybe I'll ask Sharad, since he's in that space a little bit too. I don't know. Are you running into 3D printing at all in the GIS arena?
Not much, actually, because 3D printing takes so long to print a map. It's a good model to display in the conference rooms and things like that. But beyond that, for real use perspective, we've not really seen much other than defense industry, obviously. Not in the
I'd have to say this. I have to say the same thing. I run a conference every year up in Portland, and we covered a lot of different technologies. And last year we introduced 3D printing in the conference, and it was kind of neat. We printed out a 3D topo map, and it was neat to see it. But A, it was expensive, and B, it took a long time to produce a product. And so, yes, I think it's going to be an emerging technology. It's really early in the field now. The good part about it is I think you're going to see lots and lots of consumer 3D printers, and so there's going to be lots and lots of R&D dollars being thrown at 3D printing technology at the consumer space. And so I think when we see a big push through there, that will bleed into the geospatial professional space, and maybe we'll end up seeing a lot cheaper and a lot quicker 3D printing available. But I think it's in our future. I just think it's a bit early now. Another question is, how can you ensure antenna phase center stability in low-cost GNSS receivers to provide carrier-based solutions? So basically what they're asking, I think, is how can we have a quality antenna inside a smartphone or tablet that's going to allow us to get RTK accuracy? And that's a big challenge. I mean, I've talked to a lot of people about this. In fact, some have told me that the receivers inside even the iPad or iPhone today or Android phone are able to do RTK type of computations. And the problem is that the antennas in mobile devices are so poor, they end up being a trace on a PC board, and so it's really difficult to get high precision performance out of that kind of antenna. I know Todd down at University of Austin, Texas, he showed me a slide where they recently used a standard off-the-shelf antenna from a mobile phone to do RTK, but it took this high-power computer next to it doing all the algorithm computations and such. And so I guess the real answer to me is that I think first we're going to see separate little pucks, and I've written about this, high-precision GNSS pucks that will be Bluetooth to your mobile device, your handheld or your phone or tablet. And those, you can place those anywhere, and those will have high-precision antennas on them. People, companies will invest in making quality antennas. They'll have a high-precision receiver inside them and a battery, but there'll be a separate device from the mobile device. But they'll be very small, maybe the size of a $50, something like that. And I think that'll happen actually fairly quickly. I think in the next couple of years you'll see those. And then eventually I think, when the smartphone companies start to see the upside to higher precision, maybe they'll start allocating more real estate for high precision antennas inside their devices, or maybe there'll be some technology breakthroughs that will help push that along. But it'll be a while still. But I do think you'll see small Bluetooth puck receivers, high precision receivers, over the next couple of years, because there's lots of constellations coming on board now with Galileo and Chinese BDS system and so on, that there'll be, I think RTK will continue its downward trend in pricing and be much more available for folks. So hey, I really appreciate the audience coming out today and listening to us. Sharad, I really appreciate you coming in and talking to us. You've been a great addition and a great insight into iOS and Android. I appreciate that.
Thank you very much for having me.
And look for a follow-up newsletter from me trying to address all the other questions that were received. And feel free to email with any questions or comments. And I look forward to hearing from you.
All right, well, thanks everyone for viewing today's webinar. If you'd like to view Eric's article he mentioned earlier, it should be available now on your screen. You can also view ESRI's website by clicking the ESRI logo on the left side of your console. An on-demand recording will be emailed to you tomorrow and will be available at gpsworld.com/webinars and geospatial-solutions.com/webinars. While you're visiting the GPS World and Geospatial Solutions websites, be sure to catch the on-demand version of our last webinar, How Much Farther to the Promised Land? Purchase Decisions in the Evolving Landscape of GPS, Multi-GNSS, and Alternative PNT. With the GPS World team gearing up to provide you coverage from several key fall events, including ION, CTIA's Super Mobility Week, and InterGeo, we will have lots to talk about in our next webinars, which are on the calendar for Thursday, August 14th, and Thursday, September 18th. Check back with us soon for registration information. A special thanks to ESRI and all those joining us virtually and live here at the ESRI User Conference. This is GPS World signing off from San Diego.